Okay, so for the forward propagation, just double check here. So we have kind of our x's going in, and then we have, so this is our hidden layer, and this is our output, and then, you know, okay, so we have our, you know, our W matrix, and then our X goes in, and so we have X, so that for the forward propagation, we have X times the first weight matrix, and this will become our inputs Z at the second layer, and then at the hidden layer, we will add biases. So we have our first bias matrix, which comes in here, and so we will take our Z's going in, add our first bias matrix, we apply the sigmoid function to it, okay, and this will be our activations coming out here. Then we will multiply those by our second weight matrix. These will be the inputs here. We'll add a bias, our second bias matrix, and then we apply a function to, we add our biases to this, and this will be our kind of our outputs for y hat. Okay, so now for the so this is kind of the forward propagation. All right, and then so for the back propagation, we want to find our cost function j is, we're doing 1/2 times the squared residuals, okay? And so if I take the, we'll just start with taking the partial with respect to the first bias matrix, or I mean not the first, the second bias matrix, right? So because this will give us our outputs y hat. So if we take the partial derivative of the cost function with respect to the second bias matrix, just applying this, so 2 times the 0.5 becomes 1, and so we can just have sum of y minus y hat, and y does not change with respect to the bias matrix, but y hat does, okay? So we would have to apply the chain rule to this, which means we bring out a negative there, and then we have the derivative of y hat with respect to the second bias matrix, okay? So to figure this part out, how does y hat change with respect to the second bias matrix? This requires the derivative, so we've got f prime, f is the sigmoid, and f prime would be sigmoid prime, the derivative of the sigmoid function, So we have f prime of basically this output, Z3, plus the second bias matrix, okay? And if we ask, okay, well, how does, this vary with respect to the second bias matrix? It doesn't vary at all. So Z3, there's no need to further apply the chain rule, okay? So Z3 does not vary with respect to the second bias matrix, because Z3 is just the output of the activations multiplied by the second weight matrix. So it is not affected by, does not vary with respect to the second bias matrix, and then the second bias matrix, the derivative of that will just be 1, right? So basically, this part just becomes times f prime of Z3 plus the second bias matrix, like so. Does that fit on the screen? Okay, and I think in our computer code, I have called this delta 3. Oops, sorry. Okay, is that okay for the? And then if we continue this, let me. Oops. So now if we want to continue to apply the chain rule, we'll see that Z3 is equal to A2 times W2, right? So so then if we want, how does this change with respect to the second weight matrix? Then we have to continue applying the chain rule here. I'm sorry, there shouldn't be a summation sign here. Yeah, sorry, get rid of the summation here. No summation, I apologize. Go back. Why is this way smaller? I don't know. Okay, so so basically the derivative so far is the same, but now we have to apply we continue applying the chain rule to see how this Z3 changes with respect to the second weight matrix. Okay, so keep in mind that Z3 is A2 times W2, so therefore Z3 with respect to the way Z3 changes with respect to W2 is going to be A2. Okay, and so so I can plug this in. to right there. All right, and so so I have this as y minus y hat times f prime of z3 plus this second bias matrix times A2. So this is going to be how it changes there. Okay, so and if we want to continue, then we might want to see how you know, how does A2 change with respect to the first bias matrix? Okay, so keep in mind that A2 is f of the output Z2 plus the first bias matrix. So if we ask what is derivative of A2 with respect to the first bias matrix, we would get f prime of Z2 plus B1. Okay, kind of applying that. And so then we would just plug this in up here. So we'd get dj, dw, not dw, the first bias matrix, db1, is going to be y minus y hat times f prime of times A2 times the kind of the partial of how A2 changes with respect to B1, and we'll plug this in right here. So putting it all together, so I have this. So with respect to the first bias matrix, okay? And then if we want to continue this, we then just have to ask, do any of these things change with respect to the first weight matrix, okay? And the only thing that changes with respect to the first weight matrix is going to be how does Z2 change with respect to the first weight matrix, okay? And Z2, if we ask, how does, so if we were to continue this, then the chain rule, we would say, okay, well, how does Z2 change with respect to the first weight matrix? And keep in mind that Z2 is just X times the first weight matrix. So this is going to just become X. And that's what we will have there. Okay. So if you want to continue this, continue the back propagation dj dw1, it's going to be exactly the same, everything, and then we're going to multiply this by x. Because it's just applying the chain rule. How does, you know, what changes with respect to what, and it's just going to be, okay, this changes with respect to this, this changes with respect to this, and you just continue applying that. Oh, I'm sorry. Part of these things got cut off on the edge, but are you guys able to see? All right. Does that help?
So beta 1 is just the delta 3 times f prime.
So it's going to be delta 3 times your A2 times F prime. So A2 being the output of F. So yeah, so delta 3 is how the cost changes with respect to the second bias matrix, or second bias vector, I guess. And then dj dw2 is, does that thing change? Is there anything in here that changes with respect to w2? And the answer is yes. The value z3 change with respect to w2. Okay, and that changes by being a product of A2 and W2. And what is A2? A2 itself is this thing. So this is what we have. This is what I've written here, because this is how we've written it in the forward propagation. But if you want to say, okay, well, what is this thing actually equal to? It's actually equal to all of this. All right. Is this okay? Okay, let me actually pause the video here for a second.